All right. Talking about tables, here we're talking about x and y values. The domain is your x values. Those x values, specifically, if they asked for the domain, we would write them out like this. We would say -6, 5, 4, -5, and 1. We would list them individually, okay? Whereas when we had a graph, okay, we're looking at many more. So we can say all real numbers. But when you have a table, you have a lot fewer to deal with, all right? So that's my domain. Here's my range. Here's my range. And we technically probably should write them in order from least to greatest. That would be ideal. So what's my smallest number here for the range? -12. What's my next smallest number? No? Check again. -6. Good morning. Yes, -6. And the next smallest would be 1, 3, and 4. So if they ask you for the domain and range, you list those numbers individually. Okay? Now, we need to see if it is a function. A function, you want to look at the x values. So I'm going to say, like I did before, is it a function? Question mark. So as I look, I'm looking to see that I have an x value going to a unique y value. So I have -6, I have 5, 4, -5, and 1. Do I have any repeats? No. So since I don't have any repeats, I have all different x's going to a y value. So yes, that is a function. Were you here yesterday? Need to pick up one of each of these, and we're working on the notes now. So then, now that it's a function, we need to check, is it one-to-one? Okay? First of all, it is a function. Okay? So we know that's true. And then second, we need to see, are there any repeated y values? So as I look, I see 4, 1, 3, -6, -12. Are any of those repeats? No. So that means no repeats, which is a good thing. So yes, this is also one-to-one. So yes, it's one-to-one, and yes, it is a function. Okay? Let's go to the third table. Here's my domain, the x values. Here's my range, the y values. And as I look at the domain, do I see any repeats? Any repeats? Jennifer? Any repeats? No. So, is that a function? Yes. No repeats on the x's. And then next, we need to look and see, is it one-to-one? We already know it's a function. Do I have any repeats on the range? Yes, we have 2, and that matches up with -2, and 2 matches up with 7. So that is not a one-to-one function. So this is no. not 1 to 1. Not 1 to 1. So yes, it is a function, not 1 to 1. All right, let's look at this last one on the bottom of this page. Go ahead, I want you to write domain next to where the domain is, and range next to where the range is. This is emergency. Okay. Hey. And I want you to take a look, see if you can figure out if it is a function or if it is a 1 to 1 function. Go, Jennifer. All right, let's see how we did. The domain. What is the domain here? It's your x values, right? So this is the domain. All of these x values, you would list them individually. Here's the range. That's your y values right here. Okay. We need to check, is this a function? Is it a function? Andre, what do you think? Why not? Because what? They look the same? Do we have the same individual numbers going to a different number though? So I have a 6, I have an 8, I have a -3, I have a 5, and a 1. Are they all going to some number? Yes. So that means yes, this is a function. Okay? If you press 6, it's going to go to 5. If you press 8, it's going to take you to 5. So it is a function. Okay? If you press -3, like on a Coke machine, it's going to take you and give you a 5. But when we check to see, is it 1 to 1? Yes, it is a function, because we just said that before. But are there any repeats here? So if we go in reverse, 5 would go to 6. 5 would go to 8. 5 would go to -3. 5 would go to 0. 5 would go to 1. We cannot count on the 5 going to one specific number. So it is not 1 to 1. Do you see the difference? If there are repeats in the x values when you're talking about a table, that makes it not a function. If there are repeats in the x. If there are repeats in the y or the range, then that makes it not 1 to 1. Okay? All right? Okay, let's turn the page and let's take a look at this table. You have a pencil? Might want to write down a few things. All right, so we have a table showing the number of medals that the United States won at 5 Summer Olympic Games. All right, analyze the table, determine if gold and silver medals are functions 1 to 1 or neither. Determine if gold and silver medals are functions 1 to 1 or neither. All right, so the first one, we have to look at the year as our x value, and And we need to look at the gold medals as our Y value. Okay? Year as our X, gold as our Y. So as I look at the year, 2016, 2012, 2008, is that a function? Yes, it is. Jaslyn, right? Nice. So yes, these are all different. So yes, it is a function. Then we look at the Y values, the gold. Well, in 2016, we got 46 golds. In 2012, we got 46 golds. Those are two that are the same. Okay? We also got two that were the same here. Does that mean it's 1 to 1?
Teachers, please pardon the interruption at this time. Please do a quick check of your classrooms for students who are not compliant with our personal communication device expectations. Once again, please ensure there are no headphones, devices, cell phones, any item that is outside of the expectations of the personal communication device law. Please do a quick check. Thank you.
All right. So it is not 1 to 1 because we have repeats in the Y value. Yeah. Not right now. No, this is class. You can get water during your break. All right. So yes, it is a function. No, it is not 1 to 1. We also need to look at the silver medals. That means I'm looking at the year as my X, and I'm going to look at the silver medals as my Y. So the year, is that a function? Yes, we already said it was a function for the previous one, right? So it is a function. And the qualification for if it is 1 to 1. First, it has to be a function, so it meets that first criteria. Now let's look at the silver medals. I have 37, 29, 38, 39, and 24. Do I have any repeats? No. So no repeats. Is it 1 to 1? Yes. So yes, it is 1 to 1. Do you see how that works? Chauncey. Guys, this is not sleep time. If you're going to sleep, stay at home. All right. So then there are 3 different categories of functions. They can be discrete, they can be continuous, or neither. Okay? All right. Says a continuous function, right here, down here at the bottom. A continuous function is graphed with a line or an unbroken curve. So continuous could look like this. That's not what I wanted. Could look like this. It's just a line. Or it could look like this. It's continuous. It continues and goes on. There's no break in it. All right? A function that is not continuous. It's going to be over here. Is discontinuous, and it's going to have some sort of break. So, wrong one again. Something like, I don't want that color. Something like this. And see how there's a break in it. That means at that spot, there is a break. Okay? Or you can draw a curve. And that also would be a break. It is not continuous. Most of the time, I don't think we say discontinuous. I think we just say not continuous. All right? And the last one, a discrete function, looks like a bunch of dots. So D, discrete for dots. Looks like this. A bunch of dots all over on the paper. That's discrete. So discrete for dots. All right, take a look at the bottom. Examine the functions, determine whether discrete, continuous, or neither, then state the domain and range. So we're looking at letter A at the bottom. This function is blank because it is a curve with no breaks or discontinuities. That's hard to say. The correct word there is continuous. I'm putting it above because I write a little bit bigger. Okay? You can assume the function continues forever. The domain and range are both all real numbers. Wow, they gave it to us. The domain is all real numbers. As you go to the right or to the left, it's going to continue to go all the way to the right and the left. The range, how far up and how far down, you've got arrows going all the way to the top, all the way to the bottom. Okay? Yes? No, you may not. You get about 10 minutes. You're not supposed to go about the last 10 minutes. All right, let's go to the next one. Or did I go too fast on that? The next one, this function is blank because there are continuous sections, but there is a break. So this is, and I don't like the discontinuous. This is not continuous. Not continuous because there is a break. All right? Not continuous because there is a break. Now, this one's a little bit interesting. I want to look at domain. And look, if I look to how far to the left or the right, there's arrows there. So it's going to keep going on forever and ever, but we have a break. So it is all real numbers except at 2, 1. At that exact point, it contains all the real numbers except at that point because there is a break in that line. The range, how high or how low is it going? Well, it keeps going up high to infinity. It keeps going down low to positive or negative infinity. So it too is all real numbers except at that point 2, 1, because there is the break. Okay? And the last one. The function down below is blank because it's made up of distinct points that are not connected, or dots. So when you have several dots, that means it is discrete. Dots and discrete. So the D for discrete goes with the D of dots. Now notice, these are all very specific points. That is what the graph is. It is each one of those points. So when you list the domain and the range, you have to talk about all the x values of those points. So this would be over here, -3, 1, 2, 3, 4. This point would be -1, 3. This point would be -2, -2, etc. So they have to include all of those specific x values. Here's -3, here's -2, here's -1. Here would be 1 for the x value, 3 and 4. The same with the range. Okay? So they gave you the domain and range there. Questions on anything we've covered today? All right. Please, we are done with the notes for today. Let's go back to